Hello guys, this is lecture number 10 on JEE Concepts, and in this video we are going to discuss again questions on Newton's laws, and this is the third lecture on this questions on Newton's laws. And in this video we are going to deal with some of the complicated questions related to tension in strings, through which we are going to learn a lot of important concepts. So let us begin. So the first question is, like in the arrangement shown in figure over here, all pulleys are smooth and massless. When the system is released from rest, accelerations of this block 2 and 3 relative to this block 1 are 1 meters per second square downwards and 5 meters per second square downwards. Acceleration of block 3 relative to block 4 is 0. Find the absolute accelerations of block 1, 2, 3 and 4. So yeah, this is a little bit complicated question. For this, we need to move in a certain direction that I'm going to discuss over here. So first of all, there are 3 pulleys. Let this be A, this be B and this be C. We are having 3 pulleys and 4 blocks, 1, 2, 3 and 4. So at first, I'm supposing the acceleration of this block 1 be A in this direction. And what is this direction? This direction is supposed to be plus of y. That is, I am supposing as plus y direction. Now this acceleration A of block 1 is basically with respect to ground, and that is plus A because it is in the upward direction. And so the acceleration of this pulley B will also be A, but in the downward direction with respect to ground. Now I am letting the acceleration of this fourth block as small b in the downward direction, and that is with respect to pulley B. Okay, this A acceleration of block 1 and A acceleration of pulley B is basically with respect to ground, but this B acceleration of block B downwards is with respect to pulley B, and so the acceleration of this pulley C will be plus of B, that is B in the upward direction, and again with respect to capital B, that is pulley B. And similarly, I am letting the acceleration of this block 3 as small c in the downward direction with respect to this pulley C, and so the acceleration of block 2 with respect to this pulley C will be plus of c, that is in the upward direction. So these are my assumptions for this question, and don't confuse with capital A or small a, capital B and small b. These are obvious. Now since we have already let all these accelerations, so now let me write the absolute accelerations for each and every blocks. So for block 1, the absolute acceleration will be plus of a, because that is only with respect to ground. For block 2, that is this one over here, the absolute acceleration will be this, first of all, plus c, then the acceleration of this pulley C. Why? Because this acceleration of block 2 was with respect to this pulley C, and that is also plus b. And then this pulley C acceleration was with respect to pulley B, and pulley B acceleration is in the downward direction, and that is a, so that will be minus of a. Now this pulley B acceleration was with respect to ground, so this is what the absolute acceleration of block 2 is. Now for block 3, again that will be minus of c plus of b, then minus of a, similarly as we have calculated for block 2. And for block 4, that will be this minus of b in the downward direction, and then a, minus of a. So these 4 are the absolute accelerations of 1, 2, 3 and 4th block. So let me write this in the next page. Okay, so these we have already calculated, the absolute accelerations of blocks 1, 2, 3 and 4. Now it is already given in the question that acceleration of 2 with respect to 1, that is a2 minus of a1, is what? 1 meters per second square, but in the downward direction, and we have supposed downward direction as negative. So minus of 1 meters per second square. And now we know the acceleration of second block and the first block. So let me write over here plus of c plus of b minus of a, and this minus of a is equal to minus of 1. So that is plus of c plus of b minus of 2a is equal to minus of 1. That is our first equation. Now second thing is given in the question is that acceleration of 3 with respect to 1 is equal to minus of 5 meters per second square, because again in the downward direction. So a3 minus of a1 is equal to minus of 5 meters per second square. So again we know a3, that is minus of c plus of b minus of a, and this a1 is again minus of a, that is equals to minus of 5. So this is what b minus of c minus of 2a is equal to minus of 5. This is the second equation. Now third thing given in the question is that acceleration of 3 with respect to 4, that is a3 minus of a4 is equal to 0. That is also given. So again writing a3 and a4, minus of c plus of b minus of a, then minus of a4, that is plus of b plus of a is equal to 0. So this cancelled out. We are left with 2b is equal to c, and that is the third equation. So let me write these three equations. Yeah, so now we have these three equations, and upon solving these three equations, because we have three unknowns and three equations, so we can easily solve these three equations to get the values of a, b and c. So on solving, a will be 2 meters per second square, b will be 1 meters per second square, and c will be 2 meters per second square. And since now we know the values of a, b and c, so on putting the values of a, b and c over here, we can easily find the acceleration of 1, 2, 3 and 4. So let me write over here, acceleration of 1b equal to plus of a, and a is already 2 meters per second square, so plus of 2 meters per second square. That is the answer for a1. For a2, that is plus of c plus of b minus of a. If you calculate that, you will get plus of 1 meters per second square. That is the answer for acceleration of 2. a3 will be equal to minus of c plus of b minus of a. On putting those values, that will be minus of 3 meters per second square. That will be acceleration of 3. And acceleration of 4 will be same as acceleration of 3, that is minus of 3 meters per second square, because it was already given in the questions that acceleration of 3 with respect to 4 will be 0. So this is how you need to attempt the questions, and this is how you need to solve the questions, particularly this type of questions. You just need to go through the basics. Just suppose the acceleration of 1 is plus a, then you need to see that since the acceleration of 1 is plus a, so acceleration of b will also be a, but in the negative direction, so that will be minus of a. And similarly, you have to suppose acceleration of 4, 2 and 3 blocks, and then you need to proceed as given in the questions. So just try to do this question on yourself to get more clarity. Now moving towards the next question. Now the second question is, like, determine the constraint equation which relates the accelerations of bodies, this a, b and c. Okay, this is basically the basic question in this regard. Like for solving complicated questions on tension in strings, you need to know the constraint equation. So first I'm going to discuss the long method, and then after I'm going to discuss the shortcut of how to find the relationships between the accelerations of bodies connected with the help of strings. So first of all, let me discuss the long method. And for long method, you need to actually calculate the length of strings by assuming some arbitrary lengths initially. So first of all, let me have this string, like from which starts from this here a and going like this up to here, this point. I am letting this as the length of the string as 1. Like I am letting this string as 1, and this starting from C going over here from like this up to here, like up to this, I am letting as 2. Why I am just considering up to here only? Because this is actually the common lengths, like this from here to here, then from here to here, and then from here to here. So I am neglecting this lengths in all the cases that I am gonna calculate the lengths of string 1 and 2. So first of all, I am considering from here to there this. And why I am not considering this? Because if I am considering this pulley as E, then acceleration of E will be equal to acceleration of B. That is obvious, because these are connected by a single string and the length of this string is not going to change. It will be constant. So acceleration of E, that is pulley E, will be acceleration of B. Yeah, that is clear. Now between this, I am letting this length, like this straight length, as XE, and this length from the center as XA. Then suppose this pulley as D, then this length from here to here I'm supposing as XD, and this is C. So from here to here I'm supposing this length as XC. So these are the assumptions you need to take, and you need to actually practice of letting these assumptions, because letting these assumptions are also not easy. You need to practice. So just by using these 4 variables, let me write the length of string 1, okay, and that will be what? First of all, this XA from here to here, then this XE from here to here, plus of XE, then this one from here to here. And what will be this? This will be basically XE minus of XD, because this is D, pulley D, this is XD, this is XE. So this will be XE minus of XD. Okay, so that will be the length 1. Now similarly, length of string 2 will be this and this, both will be similar, that is 2XD plus this length. And what will be this length? This length will be XC. That is already supposed. So these are basically the lengths of string 1 and string 2, which you need for determining the constraint equation, which relates the accelerations of bodies A, B and C. How? After differentiating the length of string 1 and string 2 twice. And that will be equal to 0. Why? Because length 1 and length 2 are never going to change. The lengths of the string are always constant. And that is the basic for these types of questions. So let me differentiate this length 1 2 times, then it will be 0 over here. And it will be acceleration of A plus of 2 acceleration of E minus of acceleration of D, like this. Similarly, for second, this length of string 2, this will be 0 and that will be equal to 2AD plus of AC. So we are having two equations. This is the first equation and this is the second equation. So let me write in the next slide. So we are having two equations and we need to find the relationship of acceleration between A, B and C. So we need to eliminate D from here. And how to eliminate this D? Just by multiplying equation 1 with 2 and adding with equation 2. Then that will be 2AA plus of 2 multiplied by 2 AE minus of 2AD plus of 2AD from the next equation 2 plus of AC. That will be equal to 0. So this and this cancelled out. So that will be 2AA plus of 4AE plus of AC. That will be equal to 0. But AE is equal to AB. That we have already discussed, that AE is equal to AB because of same string connection. So 2AA plus of 4AB plus of AC, that is equal to 0. And this is basically the constraint equation which relates the acceleration of A, B and C. So this is the longer method. Now if you want to take the shortcut method, then that will be something like this. First of all, you need to let tension in the string. So suppose I am letting the tension in this string as T, then this is same string which is going over here. So this will also be T because pulleys are massless, smooth and all those things, and same string. So here also be T. Now this T and T, these two will add up to give us here 2T upon writing the force balance like this over here. If you let this F, then F is equals to 2T. So this will be equal to F. So that is 2T. So this will be again 2T because the same string. And then this will be 4T because again this is F dash. F dash will be equal to 2T plus of 2T, that is 4T. Then this will be again 2T. So you just need to know the distribution of tensions along the strings. If same string and the pulleys are massless, strings are massless, the same tension will go over to the same string, like over here T. And then when these kind of arrangement will be there, then these two T's will add up to get 2T like this, because this F is equals to T plus of T, that is 2T. And again this 2T will be here, and again this 2T will be here, and here it will be 4T because 2T plus of 2T upon writing the force balance for this pulley. So now we need to find the relationship between accelerations of A, C and B. So just have the tensions, like on A the tension is 2T, on B the tension is 4T, and on C the tension is T. So you just need to multiply this 2 with acceleration of A, this 4 with acceleration of B, and this 1 with acceleration of C to get the answer. That is 2 acceleration of A plus 4 acceleration of B plus 1 acceleration of C, that is equal to 0. So this is the answer, and this is the shortcut method. And you can compare the answers, like 2AA plus of 4AB plus of AC is equal to 0, and same answer we have got. So this is the shortcut method. Just practice some more questions of this type by using this shortcut method to gain confidence in using it. Now let us move towards the next question. Now let us solve the third question. So the question is, like 3 blocks shown in figure A, B and C have the masses MA as 1 kg, MB as 2 kg and MC as 1 kg. And a time varying force in newtons, Ft is equals to 20, like this 20t. Basically it must be 20t over here. That is applied on the pulley as shown in figure, and t is in seconds. Find the relative velocity between blocks B and A. Like we need to find velocity of B with respect to A. That is the first thing. When block C has acquired a velocity of 25 meters per second, it is actually 2.5 meters per second in the question. So we need to correct the question. So that VC will be 2.5 meters per second. So we need to find the velocity of B with respect to A, like this block B with respect to A, when the velocity of C, block C, is 2.5 meters per second. That is when block C has acquired this much velocity, we need to find the velocity of B with respect to A. And G is 10 meters per second square. And both the pulleys are massless and friction is absent everywhere. Okay, this is a good question. So again, we need to suppose the tensions in the string. So let me have tension over here like T, then it will be 2T over here, and again 2T over here. Then we are going to have the gravity force on this block A. That will be mass of block A, which is 1 kg. So it will be G. For block B, it will be 2 kg. So 2G. For block C, it will be only G because mass is 1 kg. Now the question over here is, when these three blocks like block A, block B and block C are going to start moving, because at the current instant when these three blocks are resting on this floor, then there are some normal force over here, like here, here and here. But when these three blocks A, B and C just start to move in the upward direction because of the force F is equals to 20T, then it will just leave the surfaces, these three blocks, and then the normal force will going to be 0 in all the three cases. But these three blocks are not going to move at the same instances. So we need to find the instant for block A, block B and block C separately when these blocks are going to start moving in the upward direction. So our basis for finding the time will be the normal reaction, when the normal reaction will become 0. And when that normal reaction will become 0, this tension will be directly equal to this G or 2G or G that we will see. But before that, let me have this force balance over here for this pulley, and that will be F is equal to this 2T plus of 2T, that is 4T, and this F is what? 20T. So that is equal to 4T. So from here, capital T, that is tension, will be 5T. So this is a notable point, that tension is equal to 5T. Now for finding the time for each of these block A, B and C when they are going to move in the upward direction, we need to write the force balance for these three blocks, neglecting the normal reaction, because then only it is going to move. So for A, this will be something like, this is what? 2T, and this 2T is equal to G. So 2T is equal to G, and we know that this capital T is equal to 5T. So 2 multiplied by 5T is equal to 10, because this G is 10 meters per second square. So 10T is equal to T, or T is equal to 1 second. So block A will going to move after 1 second. So that minimum time is needed for block A to gain the velocity, like to just gain the velocity. Otherwise before that it will be just having normal reaction in the upward direction and it was not starting to move. So at T is equals to 1 second, block A starts moving up. So for block A starts moving up at T is equal to 1 second. Similarly for block B, this is T and this is 2G. So T is equal to 2 into 10, and this T is what? 5T, that is equals to 20. So T is equals to 4 second. So for B it is 4 seconds. Like after 4 seconds, block B starts moving up. Similarly for block C, if you find this T is equals to just G, that is 10. T is what? 5T is equal to 10. So T is equals to 2 seconds. So for block C it is 2 seconds. Like block C starts moving up at 2 seconds. So now we are having these three data: A for 1 second, B 4 second and C 2 second. Now what is given in the question, like how to proceed after this? Well, it is given that block C has acquired a velocity of 2.5 meters per second. So we need to concentrate on block C now, because we are having one known over here. Otherwise we are not having any known. So we need to proceed like this. We need to find any known things and then we need to move in that direction. So for that we need to find the acceleration of C, and that will be, for C, upward direction force T minus of G is equal to mass of C, that is 1 into A, acceleration of C. This is the equation. Now T we already know, 5T minus of 10, that is equals to AC, and this AC can be written as dVc upon dt. Now we are using the calculus, so this T can be taken to this side and we need to integrate now. Basically 5T minus of 10 dt, that is equals to dVc. Okay, so we are having this now. Now let me integrate this. So what will be the limits for this integral? Well, we know that at t is equal to 2 seconds, the velocity of C was 0, because at t is equals to 2 seconds, block C was just started to move. So that will be the limit over here. At t is equals to 2 seconds, velocity was 0, and at t is equals to say t seconds, velocity was Vc, that is 2.5. We need to find that time actually. So on integration, this will be 5t square upon 2 minus of 10t, and that is 2 to t, that is equals to Vc 0 to 2.5. So upon solving, Vc will be equal to 2.5 t square minus of 10t plus of 10, and that Vc is basically 0 to 2.5. So upon putting the value of Vc as 2.5 over here and solving, we will get t as 3 seconds. So basically what it means, that when block C has acquired a velocity of 2.5 meters per second, it is already 3 seconds, like 3 second time has already elapsed. So now we have the time t is equals to 3 seconds, and for that 3 seconds we need to find the relative velocity between blocks B and A. So what we do for now is, we are going to find the velocity of block B and block A at t is equals to 3 seconds, and then we are going to find the difference between those two, that is VB minus VA, to get the answer. So let us find velocity of B at first. Well, but B actually starts moving up at 4 seconds. So till the time 3 seconds, it has not just started moving up, and because of that it is at rest only. Like the velocity of B will be 0 at t is equals to 3 seconds. So yeah, it is already given. Like velocity of B at t is equals to 3 seconds will be equal to 0, because B starts moving up at t is equals to 4 seconds. So at t is equals to 3 seconds, the velocity of B is 0. So now we are left with only one thing, that is velocity of A. So let me find the velocity of A at t is equals to 3 seconds. And for A, the force balance is like 2t minus of G is equal to A of A, because mass is only 1 kg. So let me write for A, 2t minus of G, that is 10, is equal to mass is 1 kg, 1 into A of A. And this t is what? 5t. So this will be 10t minus of 10 is equal to d of VA upon dt. Again calculus. So this will be what? 10t minus of 10 dt integration, that is equals to dVA. And again for A, at t is equal to 1 second, it just starts moving up. So at t is equals to 1 second, velocity is 0, and at t is equals to 3 seconds, we need to find the velocity of A. So upon solving it, like 10t square upon 2 minus of 10t, and the limits 1 to 3, that is equals to V of A. Upon solving this, you will find VA as 20 meters per second, and VB is already 0, that we have discussed. And the question was like, we need to find the relative velocity between B and A. So now we have the velocity of A and the velocity of B. So the relative velocity between B and A, we can write velocity of VA with respect to B, that will be equal to VA minus of VB, that is equals to 20 minus of 0, that is equals to nothing but 20 meters per second. That is the answer. So this is the simplicity of solving complicated questions. You need to just follow the wordings of the questions and proceed in that manner with confidence by following the proper knowns and unknowns. Like it is already known here that velocity of block C is 2.5 meters per second. So we need to first find the time at which that happened. But before that, there is a catch in the question, that we need to find the time at which these blocks starts moving up, and that is the biggest catch of this question. If you do not do like that, then you will get the wrong answer. So first of all, this is very important thing, that block A starts moving up at 1 second, block B starts moving up at 4 seconds, and block C starts moving up at 2 seconds. That's why the velocity of block B at t is equals to 3 seconds comes out to be 0. And because of this known, we have found the time 3 seconds and then we proceeded to find the velocity of block B and block A at t is equals to 3 seconds, and just we found the difference between those two velocities to get the answer. So this is one of the very good question. Just see this question once more or even twice more to understand it very carefully. So now let me move to the next question. Okay, so the next question is, if masses of the blocks A and B shown in figure A and B are 10 kg and 5 kg. Okay, it is given that mass of block A is what? 10 kg, and mass of block B is what? 5 kg. In both the question, like in question A and question B. Find the acceleration of the two masses. Okay, we need to find the acceleration of the two masses. Assume all pulleys and strings are ideal. As I have discussed in the question number 2, that how to distribute the tensions, we're just going to use that shortcut over here. We're not going to use the conventional way of finding the relationship between accelerations of A and B just by writing the length of string 1, 2 like that, because that is going to take some time. And now we already know the basics. So now let me follow the basics. So here for A, let us take this as T, then this will be T, then this will also be T, and this will also be T, and this will also be T, because this is just one string. This is just one string. So throughout it will be T, like tension will be T, because pulleys and strings are ideal. Now for here, this will be 2T. And how 2T? Just balance this pulleys. Force balance. This will be TT, so this will be T plus T, 2T. And this is the same string, so it will be like 2T in this case. Similarly for this case, let this be T. Then it will be T, same string, T, T. Now this is T, this is T. Force balance for this pulley, this will be 2T and this will be 2T. So this is how you need to locate the tensions in this string. Now for this case A, let me find the relationship between acceleration of A and B. Then for A, it is like T, and for B, it is like 2T. So 1 into A of A is equal to 2 into A of B. This is the relationship between acceleration of A and B in this case. And for this case, for A, it is like 3T, this 2T plus of T, and for B, it is just T. So it is like 3 acceleration of A is equal to 1 into acceleration of B, like this. Now after that, you need to assume the acceleration in a particular direction and just write the force balance. So I am just letting this as acceleration A in this direction. Then if this is moving down, then it will be moving up, like this block B will be moving up. Similarly, if I am letting this B in this direction as A, then this will move up A in this direction as A. You should be very careful about these directions of acceleration, just by seeing the course of motion. You need to assume, you need to practice for that. It is not very tough. Now after that, we need to locate the forces. So for A, it is like having 10 kg of mass as is given. So it will be like 10g over here, and for B, it will be 5g over here. Similarly for here, it will be like 10g and here 5g. Now let me write the force balance for A, and then we are going to write for case B. So for case A, mass A, 10g minus of T is equal to 10 acceleration of A, and for B, 2T minus of 5g is equals to 5 acceleration of B. But here acceleration of A is equal to 2 into acceleration of B, that we know. So let me write once again. 10g minus of T is equal to 10 into 2ab, that is 20ab, and 2T minus of 5g is equal to 5ab. Upon solving these equations, you will get acceleration of A is equal to 20 upon 3 meters per second square in the downward direction, and acceleration of B is equal to 10 upon 3 meters per second square in the upward direction, and that will be the answer for case A. Similarly for case B for A, 3T minus of 10g is equal to 10 A, and for B, 5g minus of T is equal to 5 AB, and the relationship between A and AB is like 3AA is equal to AB. So if you just put these things over here and solve these equations, then you will get acceleration of A is equal to 10 upon 11 meters per second square in the upward direction, and acceleration of B is equal to 30 upon 11 meters per second square in the downward direction. And that is the answer. So this is how you need to proceed for these kind of questions. Like first you need to locate the tensions. I've already told you how, but again you need to practice a lot of questions for this, and then you need to proceed in a manner given in the question just by reading the questions and attempting it carefully without committing any mistake. So this is it for this video, guys, and in the next video also I'm going to discuss a lot of exciting questions. So till then, thank you.